good friend of mine. I'm always very impressed with this guy's knowledge of just about everything. Whether it comes to snort suricata, building PF-ring aware applications, log searching, JavaScript. This guy knows it all. He's just amazing, super smart guy. Those of you who are familiar with security, you use Holste, so you can thank this guy for it. So ladies and gentlemen, please join me in welcoming Mr. Martin Holste.
Thanks, Doug. Checks in the mail. I know a little bit about a few things, so I'm usually a better lessons learned kind of guy. So we'll go with that. How many of you guys saw Patrick's talk? Just a little bit ago. That was an awesome talk. We didn't coordinate it all, and we should have, because we had, I think this would have been a great collaborative double talk. But he had really good evidence, I would say, to back up kind of some of the things that he and I worked together and some things that we sort of independently found. So it was really cool to see that, in fact, stuff that I've kind of had a hunch about and started looking into seems to pan out. And that's kind of important, because when I started on this talk a while ago, I started writing it, I wasn't really sure. I felt like I had a good hunch, and it felt like I was right, but, I was kind of waiting to see if somebody else was going to come out and say, no, it's not true. And if there's something in a talk that you feel like maybe it's not true, I think that would be, if we could have a question style at the end, I think that's good. Otherwise, catching me after, and I don't hear more about it. I want to know if your experience is different, because we all have only our own experiences and what we, read about knowledge as we go on. So it was kind of important to me when I started that. The more I got into it, the more I found that it was to be right. So that was kind of the big lesson for me. Was, you find something that you think is probably right, go for it. So how many of you guys run analytics in your shop? Several? Okay, good. How many would say that you feel pretty mature in it? Okay, a little bit, yep. So I've given this talk a couple of times, and each time it seems to be about the response. I've been giving talks for a few years, and for the most part, I've gotten a really better response on this talk than some of the other ones I've given, because it seems to resonate a little bit more. And each time I find out kind of why that is, and it makes me feel good that at least we can kind of talk about some of these things and get them out there, because I think in our industry there's just so much to know and understand that having a structured conversation about some of these tough areas is really important. So if nothing else, I hope that that's what you get out of it. So you don't need to know too much more about me. Doug already went through that. There's my GitHub and Twitter handle, and I do work for FireEye. So a while back, I had the privilege of talking to Anton Chuvakin, and that he sort of went more in depth on this statement. This is right off of the web. And he's for many years kind of said stuff like this, but he's been looking at analytics for Gartner for a while, and this was a quote that really stuck out for me. So his gist here is that you already have enough tools to do your job that you're already trying to figure out all the tools you have. And then if you throw another tool in the mix, you're probably going to get some diminishing returns. And whether that tool is analytics or not is almost beside the point, but certainly for analytics, because not only is it another tool, it's a complicated tool. So his point is that we can't expect a security incident response team or a SOC to have something thrust upon them, and then it'll just magically make everything better, and we really have to watch out for that. So, the interesting thing about snake oil is not whether or not the oil comes from snakes. Snake oil definitely comes from snakes, but whether or not it provides any value is the question. And I think that is the fundamental question about analytics. So, it's not a question about whether the math is right or wrong. It's not a question about, is this algorithm executing correctly? The question is whether or not that's going to help you find a bad guy. And that's what we want to look at. Because my thesis here, and I'm up for debate on it, but what I have found so far is that it's very difficult for them to provide value on their own. So why is it that security analytics need help? So we have a number of challenges, and I think the easiest way to explain it is that it comes from other industries that were successfully using analytics. So if you're going on, let's say, Amazon or Target or any online retailer, and you are looking at an item, chances are you're going to see at the bottom, you might also want to buy this, right? Now, what is the cost for them being wrong about that analytic? Not a whole lot, right? So either you don't click on it, not their optimal scenario, but no big deal, or you do click on it, and you're like, that's not really for me. So the risk of false positive or false negative in that scenario is, almost non-existent. No one cares. It's just a shot in the dark. If it works, it works. And you can do all your A/B testing to try to drive that, but it doesn't matter. The point is that analytics came from a place that was kind of low risk, and we're trying to apply it to an area that's high risk, and that's very challenging. So we shouldn't expect it to be the magic bullet or just say, oh, this will solve all our problems, or even a significant number of problems, and I think that's an important distinction. And there's a number of reasons for that, and I think if you compare it with the retail industry, it'll kind of come out naturally. So one is the high cost of false positives and negatives. But the other problem is that the output starts from an analyst, it starts from a data scientist and is given to an analyst. And that's very different, because if you're looking at the retail industry, it's going to start from a data scientist, and then the data scientist will interpret the results. Here we have this handoff that occurs, and we'll get into that in a little bit. And then we also have some serious problems with data and challenges of making that data useful for analytics. So I wanted to use a specific example for the analytics so that we're not just talking about the entire body of work all the time. I want to focus in on one as an example and try to show sort of the pros and cons. So for credential misuse, before we can even start doing that, first we need to break down the problem and understand how would you even go about doing that. So there's a number of different things you have to do. To start with, you have to collect. You have to find all the credential uses. And that's a non-starter in some smaller environments. Just getting centralized logging, stuff like that can be very difficult. That's something that's near and dear to my heart. And so for me, I think that there's a good answer for that. But it's, for a lot of organizations, still tricky. And then after that, you still have to identify the context. So within the context, you have to identify the actor and the target, and then finally derive intent. And the derivation of intent is very difficult, sometimes impossible. But even taking that context and finding your actor implies that you know a lot about it. And the other thing is that whenever you're dealing with analytics, this is all the stuff that happened, all of your security sort of did its job for better or worse. So these are all things that passed. So the firewall said it was all good, the login was authenticated, technically even authorized, all those kinds of things. So this is all the stuff that already had a shot at knocking a potentially bad thing down, didn't do its job, and this is what's left. So we have to kind of remember that. And so we're trying to figure out the three things, the target, the actor, and the intent. So breaking things down like this is really the fundamental process of making something practical. Now let's look at sort of the opposite. So sometimes, it's easier to describe something by saying what it isn't. So we'll start with that. So something that might be impractical, and again, if you've seen a situation where this worked, yes, there are situations where any of these things will work. The question is, how often should you be trying to recreate that situation? So how about the specific situations like DNS tunneling? It has a sporadic business use case. So you're going to see a lot more exploit kit activity than you are DNS tunneling. It may work, but there's going to be a lot fewer times. Whether that's more or less valuable depends on the organization. But from a work perspective, and you're saying what should we be going after, if you're looking at a purely incidental case, then we're saying, well, there's more incidents of this kind than this kind. So we have a pretty high opportunity cost for pursuing that. And this is true not just for DNS tunneling, which is one example, but anytime you're saying, I'm going to build an analytic that goes after this one thing, you run the risk of saying, well, okay, we're going to spend a lot of time on this one thing that could shift. I mean, things move very quickly in our industry. So the other way that it might be impractical takes a lot of tuning. It's not that it won't work. You can definitely do it. Data exfil is a good example. So if you have, you're looking at just traffic anomalies, the first thing you do is start tossing out the FTP server, your CloudFront, all that kind of stuff, and then you have to add it to the whitelist. Well, now you have a whitelist problem. It's not that it won't work, but it's going to take time, and there's a lot of places where things can fail because you have more and more moving parts there. It might also be impractical if it's cost prohibitive. There are a ton of analytics which work really well on million, couple million, 10 million events, those kinds of things. But when you start doing in the billions, it's totally infeasible. Some of the things that I've seen with similarity clustering analysis, there's a lot of different ways to do that, and the vast majority require like an M by N, as in all events times all events. So you start with 100, now you're at 1,000. So that could be a real challenge to try to get from a POC into something that is going to work for the company all the time, and you may be looking at a very different proposition at that point. And then I think this is probably the most common. It's difficult to acquire the data, and even within that, there's data quality issues. So, as I said at the beginning, that I wasn't super sure about my position when I started on this talk, but I had a hunch. And I got way more sure when I came across this paper here that I cite. It's a paper that Google delivered in a lecture at Stanford in 2014, I believe. And they really underscored all of the issues that I seem to have been seeing, and it made me feel a lot more confident in my opinions. And I'll have a couple call-outs. We have a good diagram in a bit. But these are some of the things that they saw that I've seen as well. So log normalization is completely underappreciated. There's a million different reasons for that. Parsing is the first step, but then even after that, you have taxonomy issues. So calling like a domain user, domain/user versus the user. If you're trying to match up two sets, you say, well, when the user was the same, if they're prefixed a different way, or they're coming from different systems where maybe they have a middle initial, those kinds of things, that will trip up your analytic before you even start. So it's a real issue with acquiring the data. Timestamps are always a problem. Multi-line logs are a normalization issue. And then just having the right fields to do the job. Then the other problem is just being able to explain what happened. So you're not going to have a very practical analytic for a security team if you can't explain what occurred. Neural networks are a prime example of this. They can do some really cool stuff. I've played with neural networks a little bit, enough to get sort of a POC kind of result. Like, oh, this is really cool. And then if you try to say, well, how do this thing is bad, and then your analyst says, well, why was it bad? It's almost impossible to explain that, because the definition of why it's bad is the entire training set. And it's not even that it's labeled or unlabeled. It's that because of this, it might be like 2 billion records. I mean, that's a very difficult position to put your security analyst in, and they probably won't be as inclined to ask for that kind of result in the future, and it just adds to the overall problem. This was called a black box problem in this paper. So then the other problem is you have accuracy versus generality. So if you start with something, you're like, okay, this is pretty good. This is also called overfitting. I was talking to the Security Onion Conference. Who all went to the Security Onion Conference yesterday? Fair number? Okay, so the guy talking about overfitting, this is that. I'm so bad. I should be able to say so the more overfitting you do is taking something that kind of worked to start with, and you're like, well, I'll tweak it this way, and tweak it this way, and tweak it this way. And now it's working, but now it's very specific. And if you think about sort of over-specialization leading to extinction, back to kind of Patrick had talked about evolution, and that's very true in this kind of sense. So at a certain point, it's going to become less useful, right? And Robin Sommer of Growth Fame put it very well. He said, you might notice that you now know enough about the activity you're looking for that you don't need any machine learning. And what he meant by that was, by the time you've tweaked it so many times, what you end up with is a rule, not an analytic. So Google called this, when you have a ton of events to start with, and you do a really good job, and you get it down to 1%, that's still a ton of alerts. And so Google found that they could always narrow down to 1% of the employees were doing something they weren't supposed to do, in an internal audit, but it's still 500 employees a day. And so they called this signal fatigue. And the way that this manifests itself is just too many alerts for the SOC. Okay, so that's all the things sort of I wouldn't say what not to do, but some of the problems. So let's look at attempting to make this practical. And this is kind of, if you're a data scientist and you haven't gotten your pitchfork out already, you might start reaching now. So these are things that you'd say, okay, well, we're not going to do the things that we said don't always work. Now we're going to try to make it practical. So here we go. Let's try to solve a credential misuse problem. So we're going to do a standard learning thing. And so the first problem is getting labeled data sets, because especially if you're in an IR organization, you don't really know what's in your very first set. So you might go on ground and there's already an incident occurring. So you have nothing to base off of. Your ground truth is contaminated. And when you're in any organization, it's very difficult to say, yes, I am 100% sure that we don't already have, beaconing or some bad activity going on right now. So saying that you're going to look for a difference between then and now definitely has its pitfalls. It's also very difficult to extract the right features. Another callback to Patrick's talk, he talked about strings, and you have to convert those into numbers. That's very tricky to do. It can be done, but it takes a lot of time, and it's very easy to start putting too many features in, and the cost of it all goes up, and you start to get into this spiral of like, oh, now I got to do this, and now I got to do this, and now I got to do this, and that kind of goes back to the opportunity cost of it. So the straight-up machine learning on it is actually pretty difficult. And same thing with predicted behavior. So this would be if you take past activity for any one user, we'll say, and like, well, they did this, and then so because they've done this in the past, we're going to expect it to be, this such and such in the future. And if it deviates by more than a certain amount, then we want to alert on that. And that works a lot of the time. Back to Google's point, maybe 99% of the time that's right. But at any given point in time, there's a number of people on vacation. There are a number of people having something weird in their own lives occurring. Maybe, a loved one's at the hospital, logging for something weird. So weird things happen to 1% of people all the time. And that makes it that makes it such that it's actually normal to have 1% of things weird, if I can put it that way. So it's not malicious to have 1% of things being weird all the time, which means, within that 1%, you have that signal fatigue. And this, again, if you're trying to do that, you have every possible login, and you're trying to look at what the login does now. So it's not to say that you should never use those kinds of predictive behaviors or supervised learning. You can definitely use them, as long as you're going to use them in a helpful manner. So for anomaly detection, as long as you're willing to deal with a lot of the alerts, that full 1%, then that's okay. I mean, that's better than 99%, right? So let's get to 1% and then let's do something with it. The same thing you could do with some clustering stuff. So an example would be like subnet scoring. If you get, more than 5 bad guys in the same /24, okay, we'll mark that 24 bad. Those are some basic things that you could do. They're not silver bullets. You're not going to make an alert on that, but they can definitely help. And that's kind of the foundation of practical analytics. That's saying we're going to do something that's going to get us closer, but we're going to admit up front that it's not going to give us a bad guy right up front. So what are sort of the hallmarks here? It's easy to compute, it's easy to understand, and it's easy to convey. If you can do all three of those things, then there's a very good chance that what you're doing is going to be practical, and that it's not going to take too much time, and that you're definitely going to derive value. So I said I'd kind of get back to that Google paper, and from their diagram, I thought this was really good. So if you have a rules engine that's on the bottom, it starts from the security team writing rules. They put it through the rules engine, and they get alerts out that the security team looks at. That works very well, because the people that write the rules, the people that are evaluating them. But if you are starting with software engineers, and it goes through feature engineering, and then feature extraction, and then it goes through all that stuff, and then you get alerts. And as I said before, when you backtrace all that, something gets lost in translation, and that's one of the big challenges. So how do we actually how do we synthesize? Where do we start from with the practical stuff? So you start with the actual DFIR experience. Like, I know what bad looks like because I've seen it a bunch, right? So you start with the knowledge. Then you have to add in appropriate amounts of data. And for a lot of places, this is very tricky. Just getting large enough sample sizes of anything is fairly untenable in a lot of smaller organizations. And then having the technology that's going to scale it. And that doesn't mean just like building it once, it means running it day in, day out in a SOC grade scenario, which is a lot different than just getting it running on your laptop once. If you can do all three of those things, then you're pretty practical. If you're working on something and you're like, geez, I don't know if it would work all the time at scale or, in our environment, it's not that you shouldn't do it necessarily, but it may be impractical and you might not get all the value from it. So they don't flag anything good or bad. They present facts. They're not opinionated. They just say what happened. It kind of reminds me of the difference between Bro and Suricata in some ways. So Bro will just describe what happens on the network. Suricata will flag stuff as either hit a rule or didn't hit a rule. So practical analytics will not require ground truth because of all the problems that go with that. And this is the key one. They're rarely actionable by themselves. So I feel like they're often overlooked because, some stakeholder comes in and says, we need a way to find this. We just saw this, or I just read about this, or guys on the ground said, we've been seeing this, build me something that finds this. And that's not the right way to go at it. You need a much more building block approach. So, what would be the actual answer here? It's a trick question. There isn't one, and one is the key word there. So if you put some of them together, then maybe we can. So let's look at what happens if we try to just take an actual practical analytic and try to do it by itself. So if you'd say, all right, well, it's practical to be able to say this login has never happened before. That's really easy to figure out. Everyone understands it, but it's very noisy. And like I said before, people go on vacation, novel situations arise. So just saying that a login has never happened before is something that starts out being practical, but you don't get too much value out of it. You could say it's anomalous that so many things are happening at the same time, like spikes, right? Very easy to calculate. Spikes there's millions of tools that will give you spikes, but there are legit reasons for that happening, and so you can't just say, well, there's a spike, something is absolutely an incident. But we're getting closer because we fulfilled all those hallmarks, right? It's easy to compute, easy to convey, and easy to understand. So we got something here. So we need to be able to put those things together to get something that's going to definitely provide value, day in, day out. And this is the foundation of set intersection analytics. I have to give some props to a local brewery in Madison, Wisconsin, where I'm from. Proud resident. And they have a box of beer with this on the side of it. And I'm like, I must use this picture. This picture is amazing. Whenever I'm feeling, I have that picture above my desk. And if I'm feeling down, I just kind of look at it and like, be the kitty. That kitty can do anything. Look at that thing. So it can do analytics. So I approach this like a lot of things, modular building blocks. So the Unix philosophy of analytics. So each analytic does one thing and does it well. And then we're going to combine them like you would a bash script with, pipe, and then hopefully we're going to get something that's reproducible and valuable. One way you could think about it is something called strange pairs. So that's, imagine you have two lists, and it's really common to be on one, really common to be on the other, not common to be in both. Try to think. It's really common to be a quarterback. It's really common to be a wide receiver. It's uncommon to be both that way. If you guys don't want sport ball references, just start letting me know. I can do Star Trek. So then the other major part of this is assuming that so it's not unusual to combine these things, but the novel sort of approach here is that if you assume up front that you must combine them, it opens the doors to going after things, explaining to people, no, I need time to work on this, even though you're not going to get an immediate result. It's going to require patience, which is not usually what stakeholders want to hear, but you can start showing real value that way. And so to approach something knowing that it's not going to give you a final answer is a very powerful, but simple statement. So what does this kind of look like from a flow? You guys read that in the back? Is that right? Probably not. All right. So on the left, we have a detection objective. So just what are we trying to do here? And then in the middle, we have a combination of set A and set B that come from, in this case, events. And then you do a little bit of analysis. You might do a little bit of filtering and thresholding. These are just very statistical kinds of things. And then the output, and this is kind of critical, is an event. And back to the not being opinionated but being factual, this is important because events can be sent back through the whole system. So you kind of get a commodity building block out of the whole thing. And that means that not only can you put two things together, you can put two things together at different points in time. So let's look at the advantages here. Specifically, are we addressing our signal fatigue? I am arguing yes. Now we have a way to deal with any kind of lengthy output lists because we have a way to filter them. And so as an example, if you have a ton of service accounts and you filter to just first-time logins, suddenly you have a lot less first-time logins and a lot less service accounts to worry about, and you might just be under that signal fatigue limit. And so I was saying that this is a way to start approaching problems knowing you're not going to have a final answer in one step. This is basically saying that we're going to take stuff that was previously unviable and making it viable. So before I was saying, oh, we can't use machine learning, it's not going to give you a final answer. It's okay if it's a building block in the whole system. So this is where it's not that math is wrong or bad, it's just that it's only one piece of the overall puzzle. And if you know that going in, you're going to know up front, oh, we're going to also need to design this, we're going to need to have this kind of data, we're going to need to put all these things together. And this has a lot of repercussions. So suddenly stuff that was unimportant data can become important. You have an opportunity to take advantage of some things like that. So if you're looking at an overall set of events, just knowledge that was previously uninteresting for security purposes suddenly becomes interesting. So the list of everyone who downloaded an EXE is not interesting. The list of everyone who downloaded a PDF is not interesting, but you put the two together in the right time frame, that might actually become sort of interesting if you're looking at a dropper scenario from PDF exploit. And so these are just some ideas, but these are, start creating your own laundry list of very easy to collect things that suddenly become valuable when you look at them as small building blocks. So you can get the output from other analytic modules, a list of users by job role. Suddenly, just the list of people who have access to ACH transfer systems, that becomes really important all of a sudden. A list of people who are on vacation based on what Outlook says, out of office. That could be interesting. Again, that in and of itself, not that interesting, right? The list of assets that are previously compromised. This is like one of my favorite ones. Did they really remediate that box that we said was hacked 2 weeks ago? Let's check on that thing. Top browsers by time spent browsing. In my last job, we did a study for a couple of months, and we basically found that, and these are confirmed incidents, for every 1,000 unique web pages you went to, there would be one incident. So it's basically Russian roulette with a revolver with 1,000 chambers or whatever you call it. And so it was just a matter of time, basically. So you could pretty much predict how many incidents you were going to have based on how many URLs there were, to the point where I actually had a quota for my guys. Like, you didn't go home until you found me 5 incidents. And it actually worked out pretty well. But we could use some of these techniques. So just top bytes transferred, and then just some basic lists about IP information, some GUIs kind of stuff. If you have that more as less on-demand lookup, but more as a data set, that can become really valuable information. And then you can go a little bit further and combine those kind of sets with profiling. So asking very specific questions that they're not going to give you the result, was this evil or not, they're going to give you a building block style answer. So a question that you can ask that will define whether or not someone was an admin. And then a question you can ask that would say, was this an admin-like activity? And then by finding the set difference in there, you can actually get something worth investigating. Okay, so if you want to decide you want to do some of that profiling, it sounds like something pretty advanced. Not necessarily. You could pick just a set of websites, not Reddit, because that's, a little bit more widespread. But if you go to Stack Overflow and GitHub enough, you're probably a developer. Those kinds of things. Maybe you go once or twice, maybe not, but you say, you know what, you go 10 times in a week, there's a really, really good chance you're a developer. That's not necessarily like some machine learning thing, right? That's like a SQL query. But now you have this list of people who are probably developers, and that's really practical to do and valuable. Did you do any kind of RDPing? Good chance you're an admin. If you're constantly traveling all over, then you're higher risk. You're a business traveler. Did you download a whole bunch of files? Well, by definition, you're some archival software. Whether that's really what you're doing or not doesn't matter. By factual definition, that's what you're doing. So what we have here with the framework of building blocks is a bridge between the analytics and the analysts. So when I was saying that, well, the data scientists create these analytics and then hope that the output is valuable to the analyst, this is what gets you around that problem. So you're still going to need some help running stuff like this at scale from data scientists, or at least from having the infrastructure to support it. But by using that framework as the bridge between the two worlds, you can really have a more meaningful conversation and more meaningful development requirements with them, because you could say, this is exactly what I need, and this is exactly what I need, and you'll know how they've got that. And that's the critical step. So no analytics talk, I think, is complete without the obligatory visualizations. For those of you who saw my talk yesterday at Security Onion, some of this will hopefully look familiar. That was on purpose. So I think that visualizations really help to make analytics usable, and this is specifically in the early goings on, when you're trying to figure out, like when you're profiling, what does this even look like? Now, I'll give a shout out to Edward Tufte, who has written a number of books. I have to recommend them all. Beautiful Evidence was the one that I'm going to cite mostly here. I actually found it at the library. So some of those technical references you can get at the library if you're, if it's the difference between, should I spend money on this book or not read it? There is a middle ground. I do like the library a lot. So if you weren't going to read it at all, you might at least check the library. So he has a few just basic points, which I feel like as a PSA is important to say. Have readable, sensible labels. Add emphasis to important points. So you're trying to speed things up for the user, right? You're trying to make it as quick as possible. So if there's something that you know is important, then make it important on the chart. Don't just put it up there. And then don't use more screen space than it's absolutely necessary. So if you're at my talk yesterday, I have some thoughts about dashboards and that I hate them. So I think that dashboards are critical for getting you a budget, and that's where the value stops. And the reason I think that is, if you are going to a dashboard to see if something is wrong, you're probably looking for a spike, or you're looking for something that has changed, and that is something that can be scripted, and then you can get back to doing something else. So that's my opinion on that. Sometimes you just don't have the skills to do that in-house, and okay, I get it. But that, to me, should be the goal, is that a well-oiled SOC should not have anybody looking at a dashboard. They should be responding to alerts when they come in. If you're management, I get it. So I'm not going to say don't make them. You absolutely need to make some of them. But as an analyst, I would find it unfortunate if you were spending a lot of time on dashboards. However, if you're going to make them right. And these are some of the ones that I hate. And the reason that I hate them isn't because they look bad or anything. It's that you can't just look at them and have any sense as to what's going on. So you have to hover over every little thing to see what's in the legend. And that's not going to save anybody any time. That's just like, okay, we have some pie charts. So this is why I'm such a fan of the Sankey diagram. Sankey shows the same data that was in those pie charts. We have, subsections or subsectors, but it's going to show not only the amounts and how much they vary by, it's going to show the connectivity between them. So it's this whole other dimension that it provides. And you can actually read it. That's what I love about it. So you can take one look at this and okay, hey, that big thing in the middle has got a lot of connections. You can hover over that if you really need to see how much it is, but it doesn't really matter. You're not interested in the total amount. You can see by any one of those kind of stacked bar graphs exactly where the stuff is going. You should save a lot of time with time-based controls. Instead of having a user click a whole bunch of times, it's much nicer to have save them a whole zoom in, right? At the bottom you can see the entire time, and on the top you see a very specific section. So really just getting out of the way. So can anyone tell me where this is from? Anyone seen this before? This is the handwriting of Galileo. He is figuring out for the first time in human history that there are moons around Jupiter. And he did it with a little piece of glass in a tube and a quill and paper. And I think about that a lot because it's very inspiring. And it's inspiring because he was told the entire time he was wrong. And I thought it's something that it's very inspiring. So what he's doing here is each day going out and plotting where the planet Jupiter is. And then these funny little things that he doesn't know what they are on day one. But when he gets down to, it's like about the 12th or 13th, 14th day, I think, he's like, you know what? There seems to be sort of a corkscrew motion here. I think there's something actually orbiting this other place. And, I mean, the inspirational part aside, I thought this was a neat way of showing time-based stuff, especially as it changes. So I thought it'd be really fun to have a visualization that goes and shows logins that way. If you're zeroing in on just a few users, I thought this would be a quick way to show an anomaly, especially across days. Normally you see this in a calendar format, and I think that can be valuable, especially if you line them up by sort of day of the week, but I think this really gets you for a time of day comparison. I like this method. All right, so let's put it all together. Analytics are not magic, and we need to own up to that. So how would we do this with our practical analytics here for prevention misuse? All right. So what I looked at for this were a way to show this in sets with some sort of visualization on it. So there's 6 different lists there, and what I did for this was rig up back-end queries so that whenever a box is checked up there, it would pull in that data and then merge it together, and so it would like increase the counts. So the bottom, the x-axis is the username, so everything going across is the same user, or sorry, everything going across is going to, everything in a column is the same user because it's the x-axis. And then the y-axis is the number of hosts that they logged into, or sorry, the host that they logged into, and the size of the dot is the number of hosts. So in the lower left there, what you have is the same user logging in a whole bunch to one host, and then the orange dot above it, they're logging in a little bit less, but still a lot to a different host. And then those kind of straight lines that you have across there are the same username logging in once to a whole bunch of hosts. And so the idea was, all right, let's put a bunch of these building blocks together, and we don't know which ones are going to give us something interesting, but we're going to provide a format that we can play our hunches very quickly. So we start by unchecking a few, and we'd say, all right, let's look at the intersection of power users, service accounts, first-time logins, and source code servers. And it gets a little bit more interesting. You already ruled out the AD controllers and the web servers, so the big hitters are gone. You kind of accounted for those. But you still are left with a bunch. So you have four users to play with there. All right, so what if you go down even further? Now we're just looking at first-time logins to source code servers. And you only have one time that happened, and now you have, you're out of that signal fatigue area, and you're into something that you can actually start to investigate. And maybe if this happens a lot, now you can actually make a rule out of that, a repeatable process. So in conclusion, the best analytics are the simplest ones, and I think this is probably the easiest way to put this. If your analytics starts to look a lot like reporting, you're probably on the right track. It's sort of the big takeaway, and reporting is very underrated for detection purposes, I guess is the easiest way to say it. And then assume that your analytics are going to need help. So make sure that the output from those analytics is something like an event that goes into your normal analysis workflow. I think way too often you see the output from an analytic is like in and of itself a deliverable, and you have no way to go further into that and to filter it. And then that result needs to be easily communicated. That kind of goes back to the previous statement. If it's just an event that's an output, well, it can clearly be communicated because it's just like any other piece of data at that point. And then I think you need good visualizations at some level to be able to understand what's going on there. And I think they're an effective interface, especially in the early stages for playing with them and figuring out what is valuable. That's it. Glad to take questions. Go ahead.
Yes. You ever provide feedback once you start going through the analytics to the sensors themselves or the data sources? And the second is, how do you validate the physics of some of these sensors as they're being patched and modified, whatever, to ensure that you're still getting data after the patch or the change or whatever?
Okay, let me repeat the question, make sure I got it right. So do you take the output from some of these analytics and then tweak the sensors that are creating the inputs so that you get better analytics? Well, not really. And that's kind of to the first part. If you have to tweak the input, then it's not as practical anymore. So I think the best way is to try to sidestep that. If you're ending it, and that's kind of the point, if you're tweaking a lot of stuff to get your analytics to work, then it becomes impractical. Any other, there you go.
It seemed like you got
the typical data science problem where the data scientists don't have the domain knowledge and the analysts with the domain knowledge don't have data science knowledge. Especially like mentioning the Google paper where the feature set generation is done by the data scientists who lacks the domain knowledge on which features they want. You find that we're just not combining teams right to get the analytics correct up front.
Yes, that's an excellent point/question. That is strongly the case. I feel that a lot of times there's both some siloing that goes on, I think, in most orgs, but beyond that, that's kind of the point of that bridge picture, was that you need almost a language or a framework to communicate between the two disciplines. And so by each group kind of meeting in the middle, where you hear your analysts, we're all smart folks. We can do some math, we can figure out some stuff, but we don't have all day to sit there and read research papers. So if you can get it to us in something like standard deviation or average, some statistical functions we're going to understand. If you can get it to us that way, we're good. And on the other side, they certainly know how to do that. So if you kind of have the smaller building blocks that don't require nearly as much machine learning and training sets and those kinds of things, you're going to have much shorter conversations and more quality conversations between the two. And once you start getting some successes there, I think that the teams just sort of naturally start to communicate more, and then I think the problem starts to solve itself like that. The interdisciplinary knowledge sharing really starts to blossom. Great point/question. More questions? Heckles are welcome. Challenges are welcome. Oh, yes?
Now your slides are available. Eventually you go back to your hallmarks, practical analytics slide, you have 3 points. I just wanted to make a note about it.
Sure. All right, while I'm doing that, any other questions? All right, I have a couple of giveaways here. I should have made this the question, but there was a previous slide, looked similar, also had 3 points on it. And it was how you know if an analytic is practical, related, but slightly different. There were 3 points. Okay, go. Yeah, yep. Nice. These are both by Ruffian and he was more Ruffian named Jason. Okay, I have one more book to give away. By another dear colleague, Richard Baitlick. Let's see. What are the 2 kinds of machine learning? Try that first. Correct. All right.